All right, 102 students, I'm going to try another one here. This is chapter 4, number 1 in the exercises. And maybe the first thing I should say is go back and look at my video solution for conceptual number 6. Because what I'm about to say, I'll say kind of quickly, I cover in more detail here, and it has to do with direction. And so let me point out that in physics, the number, the unit, and the direction are all extremely important. If you were to have something, and I guess I'll just use the same example I did in number 6. If you had something, say, moving, and so I got this little object and it's moving, I can say it's moving at, and I'll just say 3 or 4. Well, 4 is bigger than 3. So you might say, okay, what's the difference between a 3 and a 4? And I think most of you know that answer. I don't need to explain that, 4 is a bigger number, and hence we'd say it's moving faster than a 3. Okay, but clearly the number matters. But I would say also the unit matters. Is it moving forward at 3 meters per second or 3 kilometers per second? I think in the other video I used miles and mixed my units. But either way, I think you'll see that the units here are important. You need to do more than just a number. You got to also say what units are. Because, 3 millimeters per second is really slow. 3 kilometers per second is really fast. And 3 meters per second is a mediocre speed. Okay? So that units are important. Absolutely, as well as the numbers, but also the direction. And so if something is moving to the north, it's important we know that. Because if something is pushing it to the south, so I have a force to the south, but it's moving to the north, that slows it down. But had the force been in the same direction it was moving north, that would speed it up. Or if the force was over here to the east, that would make it turn. And so knowing direction is crucial. And so that's what these beginning chapters are hopefully helping you to understand, that the physical world needs a number, it needs a unit, but it also needs a direction. And we call these vectors, and we did a lab to help us with vectors on it. Our second lab was designed purposely for that. Okay, well, this problem is only one-dimensional. It's not two-dimensional, so the direction's a little bit easier. But let me do this. I guess I'll kind of draw the same picture I did in Conceptual 6, where I said, look, if you have a vector going this way, and in that problem I was using velocity as the vector. So let me draw an arrowhead, which is initial velocity. And then let me draw then later on, our velocity was angled down. That would be final velocity. I was asking, what is the arrowhead from the head of the initial going to the tip of the final? And I wrote it as question mark. And I tried to explain it this way. Since we add vectors, drawing them head to tail, we would say that the initial velocity plus this question mark vector would equal then the final velocity. Or question mark is then final minus initial. So a good visual representation then of the direction of the change, see, minus the change. So question mark is the change. But if you're subtracting two vectors, then drawing it from the initial vector to the final vector is how you get the change. Now, for this particular problem here, so for number 1 and then number 1a, the first one says that we have 5 meters per second to the west. So if we do our kind of our traditional compass rose, north, east, south, and west. Never eat soggy waffles. The initial, it says, is 5 to the west. So there would be my initial. And then it becomes 10 to the west. So let me draw a second one. I'll draw it just below it so I don't draw it on top. And there's a 10. So it's longer to the west. So coming back up to here, the way I would draw a difference is I would draw it from the tip of initial and going to the head of the final. So that would be from here to here. So it would have a length of 5, and we're in units of meters per second, and it's pointing west. So it would be 5 meters per second west. We could say the same thing here with B. Let me do a compass rose again. The initial is 10 to the west. Okay, so I'm going to draw it 10 to the west. So that's initial right there. And it becomes then 5 to the east. Okay, so drawing from the tip of the initial to the head of the final, I would draw a distance of 5 in units of meters per second, and it's pointing to the right here. It's pointing east. And so there is a difference between these two. They have the same number and the same units, but they point in different directions. And as we were saying earlier, the direction matters. And so these are not the same vectors. One points west and one points east. And the last one, I don't know if it deserves a whole piece of paper, so I'll flip it over here and make a compass rose. But it says it is initially 5 to the west, so I'll draw initial, and it becomes 10 to the east. So we would draw an arrowhead from the beginning of the initial, from the head of the initial to the head of the final. And that would be a longer distance, so that's 15 meters per second. And you can see it's pointing towards the east. And so I got 15 east. All right. Hope that helped in terms of pictures. Of course, you could do just the math here and subtract things. And, or you just, use numbers such as since we're doing east and west, traditionally to the right is positive and the left is negative. So if you said final minus initial here, you might say for A, the final is 10 meters per second, and since it's west, you might call it a negative number. Minus, and then the initial is 5 meters per second, and it's west, so you might call that a negative. And so you're going to end up here, two negatives make a positive, with a negative 5 meters per second, and again the negative being west. So that's the same thing we got here, drawing our pictures. Probably better you understand the pictures. That's really, I think, what the author's after, but you can see it in the math that you'd get a negative 5. A B would look like this. You would go final minus initial. So final would be 5 meters per second, and it would be west. So I'm going to call that a negative. And then you would minus the initial, which is 10 meters per second, and also west. And so when you take a negative 5 and subtract a negative 10, the two negatives here make a positive, and you end up with a positive 5 meters per second. So there would be the 5, and you would get an east out of it because of the positive. So that's what we got here in B. And then C, if you're, again, just kind of doing the math without too much visualization, you would just say final, which would be 10 meters per second to the east, so it would be positive, minus the initial, which was 5 meters per second in the west. And then the two negatives make a positive, so we're looking at a positive 15 meters per second. And again, that's what we got in the picture. We got 15, we got the positive for the east. So that works too. All right. Take care, everybody.